Hello students, welcome to EDAMIGO, an initiative by GATE ECE Top 3 Rankers. I welcome you all to the lecture series on previous year GATE questions on the subject of Signals and Systems, Electronics and Communication branch, and the topic is Basics of Signals and Systems. Here we are solving the questions and analyzing the concepts on which the questions are based. We have already covered 8 parts of the lecture series and this is the 9th part. So if you have not gone through all the 8 parts, so please go through the 8 parts and you will see that the questions are solved in a very religious manner and the concepts are also explained of each and every question. So let's start with the part 9. So let's start with the questions. So this is first question of the part 9. So here it is given that again we can see that the question is based on convolution of two discrete time signals, and we have seen that there are many previous year questions based on the same concept, and we know the concept, we know the method how to convolve the two discrete signals. So yn is equals to xn convolve hn. Here it is given that hn is equal to 1, -1 and 2, and it is 0 otherwise. Okay, it is given that xn is equals to xn has x0 and x2 only and value is 1, so 1 0 1, and it is like this. Okay, now we have to find the number of non-zero samples in the output sequence yn and value of y2. Now we know how to convolve. Okay, we know how to convolve. First of all, we write h0, h1 and h2, x0, x1 and x2, and then we will multiply and add and find out the values of yn. So h0 is 1, -1 and 2, 1 0 and 1. Now we will multiply the terms. We will multiply 1, so it is 1 -1 2. We will multiply 0, put a cross, so it is 0 0 and 0. Then 2 cross, then we will multiply 1, so it is 1 -1 and 2, and then we will add the terms. So we'll get 1 -1 3 -1 2. This is y0, this is y1, y2, y3, y4. Okay, so there are only 1 2 3 4 5 non-zero terms in yn, and we have to find the value of y2. Okay, so we can see that this is y0, y1 and y2, so this is y2. So 5 non-zero terms and y2 is equal to 3. Okay, so the answer to the question is 5, 3, that is D is a correct answer. Okay, so this was a simple question, simple based on convolution. Okay, this is another question. Here it is given that ht, that is the impulse response of the LTI system, it is given that e to power alpha t ut, e to power beta t u of minus t. Okay, so we have to find the value of alpha and beta, the conditions for alpha and beta, so that the system is stable. Okay, now as we have seen in the previous section of the lecture series, that for stability ht should be absolutely integrable. Okay, that is minus infinity to infinity, mod of ht should be, mod of ht dt should be less than infinity. Okay, so if I break ht in two parts, that is e to power alpha t ut, and the second part is e to power beta t u of minus t. So the first part is e to power alpha t ut. Now for this signal to be absolutely integrable, it should be a decaying signal. Okay, it should be a decaying signal. At t equal to 0, the value is 1, but as t tends to infinity, the signal should decay and it should be like this. And for this to happen, we need alpha should be negative. That is, alpha should be a negative value, should be a less than 0 value. Okay, then only the integration of e to power alpha t ut is finite. Otherwise, if alpha is positive, then the signal will rise to infinity like this, and the integration will never be absolute or will never be a finite value. So we can see that alpha should be negative. Now if we look at the second part of the signal, that is e to power beta t ut, u of minus t. Okay. Now the signal is on the, for the negative values of t on this half, that is on the second quadrant in this. Now we can see that at t equal to 0, the value is 1.0 again. Now if the value of beta is negative, okay, beta is negative, and we know that t is also negative, so e to power will be a positive value and it will keep rising. It will keep rising towards infinity and it will be a non-absolutely integrable signal. Here beta has to be positive so that when t is negative, then e to power is a negative value and the signal decays, and at t equal to minus infinity, this is a 0 value and thus this becomes absolutely integrable signal. Okay, so we can see that for absolutely integrable impulse response ht, we need alpha should be negative and beta should be positive. Okay, so this is the answer. So alpha should be negative and beta should be positive. So D is the correct answer to the question. Okay, now let's solve another question. This is again a very simple question. So xt and yt, here xt is the input and yt is the output. We have to find that which of the system is a causal system. Okay, now as we know the definition of causal system, we have seen the definition of causal system in the previous section of the lecture series. So causal system means present output must not depend on future input. Okay, now if we see option A, then here yt is equals to x of t minus 2 and x of t plus 4. So we can see that the present value, that is yt, is dependent on the future value, that is xt plus 4. So this is non-causal system. Option B, yt equals to t times of xt plus 1 minus 4xt plus 1. Now we can see that the present value of output, that is yt, is dependent on future input, that is xt plus 1, and future input, that is xt plus 1. So it is again non-causal. Let's see option C. Yt is equals to txt minus 1 plus 4xt minus 1. Now here we can see that xt minus 1 is a past input. Here also xt minus 1 is a past input. So the present output is dependent on past input and past input. So it's a causal system and thus C is the answer. And if you look at D, you can see that the present output is dependent on xt plus 5. So future input. So it is again non-causal. So C is the correct answer to the question. So here we stop in this part. So few questions are left in the lecture series. We will be continuing the same topic in the next part of the lecture series. So thank you students. Keep sharing these lectures and subscribe to the channel. Also give us the feedback. Thank you.